Welcome to solverfy.
For this question, they are wanting us to use this balanced equation to find the total pressure and partial pressure of the gases in the system, and they have given us knowns to help us solve this. So they tell us that the volume of our container is equal to 950 liters. They tell us that the partial pressure, so partial pressure for O2 is equal to 0.64 atmospheres. They also tell us that the total pressure is equal to 1.05 atmospheres. And we need to find the partial pressure for nitrogen in atmospheres. All right, so we know that there is nitrogen introduced into the system. So we know that the pressure for nitrogen is going to equal the total pressure minus the pressure of O2. So we know that the nitrogen pressure is going to be 1.05 atmospheres minus 0.64 atmospheres. So our pressure for nitrogen is going to be 0.41 atmospheres. All right, and they also tell us that after the reaction has happened, only 85% of the O2 has been consumed. So that still means that we have 15% O2 still there. So let's find the partial pressure of sulfur dioxide. So to do this, we're going to have to go back up to our balanced chemical equation. So we see that for every 8 moles of sulfur dioxide, we have 11 moles of O2. So we're going to be using this molar ratio so that way we get the correct mole or the correct atmosphere for sulfur dioxide. So we have 8 moles SO2 for every 11 moles of O2. We're going to times this by the pressure for oxygen, so 0.64 atmospheres. We're going to times that by the volume in liters, and we're going to divide that by RT. And we know that there's 85% O2 remaining, so we have to account for that. So 85 divided by 100, because we want to get it out of percent form. And then we're going to times this by RT over our volume. So that way we can get these two things to cancel out. So when we calculate our molar ratio of sulfur dioxide, oxygen, and using the atmosphere for, or the pressure for O2, and accounting for the 85% oxygen consumed, our pressure for sulfur dioxide is going to be 0.396 atmospheres. All right, and then we are wanting the partial pressure for oxygen. So we know that it's initially 0.64. So we're going to times that by 15% because we have 15% remaining once the reaction has taken place. So after the reaction has taken place, our pressure for oxygen is going to be 0.096 atmospheres. All right, and this is our pressure for oxygen. So now to get the total pressure, we just add all the partial pressures together. So 0.41 atmospheres for nitrogen plus 0.3 0.0396 atmospheres for sulfur dioxide plus 0.096 atmospheres for oxygen. So when we add this together, our total pressure is going to be 0.902 atmospheres. And this is our P total. Alright, and this is how we find the partial pressures for all the gases and the total pressure in the system.